And I've drawn a couple of drawings, and this is dealing with the second derivative of a function. Essentially, if the second derivative is negative, we consider this to be concave down. And if the second derivative is positive, we consider this to be concave up. Now, in physics, a lot of times you talk about concave and convex. You don't really use the terminology of concave up and concave down. But in calculus, we don't really have a convex. You're either concave up or you're concave down. Now, notice also that the second derivative really does not have anything to do with the first derivative as far as whether it's going to be positive or negative. You're not going to take a second derivative, see that it's negative, and automatically know something about the first derivative. Because if the second derivative is negative, this is what it looks like if the second derivative is negative and your first derivative is positive. This is what it looks like for your second derivative to be negative and your first derivative to be negative. Likewise, over here with the concave up portion of it. Second derivative is positive, first derivative is negative, second derivative is positive, first derivative is positive. So you think about it as being concave up and increasing, concave up and decreasing, concave down and increasing, concave down and decreasing. So it's a combination of those things. Now, having said that, we're going to eventually get to where we use this information in order to construct graphs. Not quite there yet, but I think you can start picturing some of this stuff in your head. So I'm going to hand you out another packet real quick. This is dealing with what we're talking about right now. So just going to go with a basic problem. So from section 3.4, look at question number 14. So we get here, we want to take the first derivative of this function. So f prime of x is equal to negative 3x squared plus 12x. We're not going to do anything with that for right now. Later on problems, we're going to involve stuff with the first derivative. But for right now, we're not going to do anything with that. But what we will look at is the second derivative. And we're going to do some stuff with this. So we get negative 6x plus 12. Correct?
Yes.
Okay. So where is this equal to 0?
2.
Now, when we were dealing with the first derivative, and that 2 value was part of the domain, we would go ahead and say, we know that this is a critical number. But here, we don't know for sure what's happening. In the first derivative, it was a critical number if it was increasing on one side and decreasing on the other side, or it could be increasing on one side and increasing on the other side. We didn't have to change increasing to decreasing, or likewise decreasing to increasing for it to be a critical number. But for a point of inflection, which is what we're dealing with here, this value has to be in the domain, and we have to change. We have to change from being concave down to concave up, or we change from concave up to concave down at this point in order for it to be a point of inflection. So let's determine what's happening. Here's 2 on the number line. Now again, this number line is not sufficient evidence for the AP test, but it's a good guide to get you started, and you can put it into wording. But let's think about what f double prime of 0 would be, and what f double prime of, I don't know, let's say 3. All right, so we go here. If I plug in 0, what kind of answer do I get? Positive or negative?
Positive.
Positive. So because it's positive, the second derivative is positive, we know we're in an interval that is concave up. Plug in the 3, negative 6 times 3 is negative 18, negative 18.
Negative.
It's going to be negative.
Down.
So, we do have a point of inflection here. Now, to actually find that point, or to find any point, we always take the domain value and plug it into the original equation. So what do we get for f of 2 here? Very good. So the point of inflection is 211.
So we're using the second derivative to find point of inflection, basically.
Yes. The second, for right now, the question was, are we using the second derivative to find the point of inflection? That's one of the things you can find with the second derivative. That's not everything dealing with the second derivative. In fact, well, let's do, y'all do question 16 on your own.